Welcome to Life Made Up of Questions. So today we are having Dr. Prajof Prabhakaran. So I will just go through his profile. It's a brief profile. Dr. Prajof Prabhakaran is from Bangalore, but with ancestral roots from the North Malabar region of Kerala. He did his schooling from Kendriya Vidyalaya, Bangalore, received his BTech degree in Electrical and Electronics Engineering from Amrita University, Coimbatore, followed by the MTech degree in Power Electronics from Amrita University, Coimbatore. He received his PhD degree in Electrical Engineering from the Indian Institute of Technology, Bombay in 2018. His doctoral research was focused on DC microgrids and have published for IEEE transactions and 5 IEEE international conferences from his research works. From July 2011 to June 2013, he worked as assistant professor in the Department of Electrical and Electronics Engineering, Amrita University, Coimbatore. From 2013 to 2018, he worked as a teaching assistant and a lab coordinator at the Applied Power Electronics Lab, IIT Bombay. After a brief stint with the National Institute of Technology, Calicut, as an ad hoc faculty during July to November, he joined the Transportation Solutions Department, L&D Technological Services, Bangalore, where he worked for years as a project lead for the research and development of powertrain and battery management system for electric vehicle. On 4th of December 2019, he joined the National Institute of Technology, Karnataka, Surathkal, where he is working as assistant professor in the Department of Electrical and Electronics Engineering. He worked in the field of power electronics, focusing on renewable energy source-based systems, microgrids, and electric vehicles. His research interests are power electronic application to renewable energy, electric vehicle powertrain, EV charger and battery management system of electric vehicle, novel power converter topologies with improved efficiency, reliability, and power density, control of grid-tied inverters and DC-DC converters, operation architecture, power quality and control of microgrids, optimized design of power electronic converters, microcontrollers, and their application to power electronics, etc. So welcome, Dr. Prajof Prabhakaran.
Yeah, thank you so much, Dr. Hari Krishnan. It is really a pleasure and honor to be, having this interactive session with you. Thank you so much.
Yeah, there may be little error while reading out this brief profile due to the long.
Yeah. You could have shortened it, no problem.
Yeah. So now we all know that. Let's start now. We all know that the electric vehicles are undergoing a revolution all over the world. Like replacing the traditional diesel petrol engine. So for the general idea of this emerging technology, we are all interested in have an introduction to electric vehicles, first of all.
Okay, yeah, thanks for that question. Actually, electric vehicles is something, it is not a new concept. It's been very old. If you see the electric vehicle technology, it is much older than the IC engine vehicle technology. Okay. In fact, if you see the concept of first vehicles, it was all electric vehicle. Okay. The concept was, proposed way back in 1830s, but it came into prominence in somewhere in 1880s, where people especially United States and some of the European countries, they were using electric vehicles. 1880s also was a period where both electric vehicles and IC engine vehicles coexisted. Now, when I say electric vehicles powered by mainly from battery, where we have an electric motor, which is used for propulsion. Okay. And IC engine vehicles is, IC engine is, utilizes where the, the energy from the fossil fuels is utilized for the propulsion. Okay, so if you look at the period 1880s to say somewhere in early 1900, we had both electric vehicles and IC engine vehicles existing side by side. And during those days, electric vehicles, had an upper hand. Okay, mainly because IC engine technology was not so was not so advanced as it is how it is today. And also in those days, the IC engine vehicles were not self-starting. We need manually had to be started. So it was not that popular. Okay. But things started changing from 1910 onwards, mainly after the, the invention by Henry Ford, Henry Ford and company. They came up with a lot of patents, especially self-starters. and the IC engine performance was drastically improved. And even if you look into the fossil fuel mining sites, now the Gulf oil was discovered, the oil in Texas in US were discovered. So all this changed the game. Okay, so from 1910 onwards, or I would say from 1930 onwards, electric vehicle entered in sort of a dark age. Okay, it was not that electric vehicle never existed; it existed, but only as a demonstration vehicle, and our commercial vehicles. Okay, but somewhere in 1970s, there was another event that took place in the world. Mainly, Gulf War took place, and the prices of fossil fuel increased like anything. And people also realized that fossil fuels are not going to stay for long. It might get over by maybe the end of the century. And the harmful effects of the fossil fuels were also studied. So from 1970 onwards, the invention on the more focus was given on electric vehicles. At the same period, there was another revolution taking place, the revolution in the electronics field that is happening after 1950s. Okay, so after that, with electronics and power electronics, electric vehicles performance was on par with IC engine vehicles. Today, it's if you look at except the batteries, all other components, the electric vehicles beats the IC engine vehicles, and that's where the revolution of electric vehicles has taken place. And today, it is seen as a solution to for our for overcoming for our energy security, to reduce the environmental pollutions, and that's the focus in electric vehicles. Yeah.
So we got an idea about the introduction of electric vehicles. It was started from long back, but now only we are much into the market or the application level. So why these electric vehicles? Because making a comparison regarding the power, the performance, or the service, or the guarantee related to the traditional fuel engines, what are the advantages and the disadvantages associated with electric vehicles? Why electric vehicles?
Yeah, why electric vehicles is a very good question. People have a wrong notion that electric vehicles means completely a green technology. There is no pollution. Well, that's a bit wrong. Electric vehicle also consumes fossil fuels because we need to charge the vehicles. To charge the vehicles, we need to take power from our power outlet. And if you look at how electricity is generated today in our country, not only in our country, but most of the countries around the world, it is mainly from coal. And coal is not such a good energy compared to, say, gasoline or diesel. Petrol or diesel, it is not that good. But there is one thing that makes electric vehicles separated from an IC engine vehicle. That is the performance of the electric motors. If you try comparing the performance of electric motors with the IC engine, a normal IC engine vehicle, electric motors has got very little moving parts. In fact, if you see an IC engine, it's a very complex mechanical component. It has large number of components, whereas electric motors, it even for an IC engine vehicle, most of it we require gears. Okay, one problem with IC engine vehicle is we need gears. Why gears? Because IC engine does not give very good performance at starting. Similarly, at cruising, you need to have different torque speed characteristics. But in electric motors, for the entire speed range, we have a very good characteristics. Even if you see the efficiency of an electric motor, it is far better, much better than the an IC engine. So, okay. So that is one main advantage. But as I said, electric vehicle is not a completely green. It's not that it doesn't consume any fossil fuel. It does consume fossil fuel. But if you look at the efficiency of the electric vehicle, now there is a term that we generally use. It's called well-to-wheel efficiency. Well-to-wheel efficiency means for an IC engine vehicle, the amount of energy that goes in mining the fossil fuels, transporting it. When it comes to transporting it, we need to refine it, and then back to the petrol station, and then to the vehicle, and then to the wheel. So it is called well-to-wheel. Well from the well to the wheel. So well-to-wheel efficiency of an IC engine vehicle is somewhere close to around 16%, whereas for an electric vehicle, it is greater than 25%, around 25 to 28%. So both electric vehicles and IC engine vehicles consume fossil fuels, but electric vehicles consumes less fossil fuels compared to IC engine vehicles. And this can also, the difference can be increased if we go with more renewable energy for generating electricity. So our dependence on coal will further reduce. And if you see the carbon footprint in that case produced by electric vehicles, it will be much less. Okay, so that is one of the reasons why electric vehicles is so popular, because we know that electric vehicle consume fossil fuels, but it is less. Now, even if you are able to save 2%, no, if you are able to, that is it makes a huge difference. Because if you see today, the most of the pollution coming from fossil fuel is from the transportation sector. No, one of the main source of the pollution from the burning the fossil fuels is from the transportation sector. So if you are able to save, I'm just per car, I'm just giving you an example. If per car, if you are able to save, say 5 liters, it makes a huge difference, because you multiply by the numbers, it makes a huge difference. And that's why the focus on electric vehicles. And that is the reason why we need electric vehicles. And I think that would answer your question, why electric vehicles?
Yeah. So next I'm thinking your main specialization is on power electronics. So
Yeah.
what is power electronics actually? It's a semiconductor device like switching, converting one form of energy to another. So what is the application of power electronics in this electric vehicles, and what are the future forecasted applications of power electronics in other fields, mainly in electric vehicles?
Yeah, that's also a very interesting question. Some people might wonder, why power electronics and how is it related to electric vehicles? Well, power electronics mainly, deals with application of electronics, power electronic devices for control and conversion of electric power. Okay. We have electric power in various forms. What we see in our home, the outlet AC, the plug outlet, it is an AC voltage. It is an alternating current voltage. Okay. Whereas what we store the electricity, it's mainly in DC. The batteries produce DC voltage. Now, different loads need different, different electrical loads needs different type of voltage. For example, if you take, say, the mixie that we use in our home, or the grinders that we use in our home, they need AC waveform for its operation. But if you look at some of the modern loads, like the electronic loads, the mobiles, they all need DC. Okay. So we have power in one form, but we need power in another form. So that's why we use power electronics. And power electronics has got numerous applications, starting from our all the modern consumer electronic loads. Their power supplies are, it's mainly power electronics. Even our PC, even if you open a desktop PC, if you open the CPU, you find something called SMPS, switch mode power supply. That is basically a power electronic converter. Okay. Now the question, why power electronics into electric vehicles? That so that would really, we need to answer this question, that why did electric vehicle didn't become popular in the early period of 1990s? Well, it didn't become popular because there was no technology those days for proper conversion and control of this electric power. Okay. Power electronics started picking up after 1950s, where with the invention of power by BJT, which is BJT is bipolar junction transistor, which revolutionized many of the electronics. Even today, computers are possible because of the invention of the BJT. Okay. So that was all developed at signal level. When I say signal level, at low power level. But high power electronics started developing somewhere in 60s and 70s with the invention of thyristors. And people realized that, now I think by 1980s, the power electronics reached a particular maturity level where it could be applied into electric vehicles. Now, why in electric vehicles? Well, in electric vehicles, we have electric motor and a battery. Now, if you see the battery, it is DC. Okay, it produces DC. But electric motors needs AC. So you need some sort of a power conversion. So if somebody asks what is power electronics in electric vehicle, I would say it's the heart of the electric vehicle system, because it converts the power, DC power of the battery, to an appropriate form to the electric motor for the propulsion. Not only that, you can also control the speed of the motor, and the torque requirement of the motor through power electronic systems. So that is one main reason why we have power electronics in electric vehicles. Today, electric vehicles are popular mainly because of the advancements in power electronics.
So now we are telling the lot of advantages related with power electronics applications in electric vehicles. But still, in the current scenario, we can see these electric vehicles are on a research and development phase. It's not into that much like popularized in India so far. And we can see recently a news came that a lot of electric vehicles are facing some security, or it's not that much safe. like some blast is happening. So what are the causes or the safety measures while now undergoing under this phase?
Correct. See, one of the major bottleneck in electric vehicles is the batteries. Okay, it is not the power electronics or it is not the electric motor that is the problem. The problem lies mainly in batteries. Now, if you see the different battery technology that is being used for electric vehicles, I think before 1990s it was mainly lead acid. Now, lead acid battery is something that we use in our homes, say for UPS, or even in our conventional vehicle, we have a 12-volt lead acid battery. Lead acid advantage is it's more stable; it will not explode. I think so many lead acid batteries are being used, but nobody hears them exploding. Okay, it's very rare that we hear lead acid battery exploding. It is no battery is not something that we are using it now in electric vehicles. It is being used long back. Only thing is, even today, if you see all the conventional vehicles, we have lead acid battery, which is required for starting our car or starting the two-wheelers. Okay. The advantage, as I said, it is more stable. But problem with lead acid, if you say if I don't use my car for 2 months, I can observe that my vehicle battery dies. Now, one would wonder why a battery which is not being utilized, gets the gets the charge depleted. Well, one problem with lead acid is it has got high self-discharge rate. Now, self-discharge rate means it will discharge by itself without connecting any load. It will discharge by itself, and that is more in lead acid. And another problem with lead acid is its energy density is very poor, and energy and power density. Uh, what does it mean? Means, say, for example, if we need, say, I'm just giving an example, 100 kilowatt hour energy for driving a vehicle. If you see the size of the lead acid, it will be much bulky compared to some of the modern batteries. So that's why lead acid didn't pick up in electric vehicles. So it was used in early 90s, I think till 1990, late 90s, lead acids were used. But the main issue why it didn't become popular with electric vehicle is the size was very bulky. And in vehicles, whenever size becomes bulky, that acts as a load to the vehicle. Okay, but things revolutionized with an invention of one battery technology. It is called lithium ion. Okay, lithium ion I think came up in 1970s, and it was commercialized by Sony, a company called Sony, for consumer electronic products. And that's where mobile phones, laptops are all become very famous, mainly because of the invention of lithium ion. And people realize that lithium ion is a very good alternative for as a for the electric vehicles. Instead of lead acid, we can use lithium ion. But there is one problem with lithium ion: it is not a stable battery. It has a limited operating range. Okay, when I say operating range, the voltage range is limited, the temperature range is limited. Any violation in these values can lead to an explosion. So that is where we see mobile phones battery exploding, because mobile phone has a lead acid battery. We can see power banks are not allowed in our aircrafts, in their hand lug and in this thing. That's mainly because it is made up of lithium ion batteries. So that is the main problem. The problem not lies with the power electronics, it is the battery chemistry. But that is one reason. And another reason is lithium ion's life is limited. And I think today, a decade back, lithium ion they would give a guarantee of maximum 3 years. Today they're giving 5 years and expecting a life of around 8 to 10 years. Okay. But what I am seeing is in today's research, this research is actually mainly done by material science engineers, where people from chemistry and chemical engineering background try to work and come up with new battery chemistry. From whatever research papers I have seen in that field, it's not my field, whatever I've seen in that field, there are promising research where they are trying to come up with some drawbacks faced by the conventional lithium ion. Yes, today there is a bottleneck there is an issue with the lithium ion, but I would say in another 5 to 10 years, hoping that these issues would be solved. And whatever we read in the newspaper, this explosion, it is only because of these constraints getting violated. I know that lithium ion, the operating temperature range should be somewhere minus 25 to 55 degrees centigrade. And in our country, we have, our summers itself touches 40, 45, in some places 50 degrees. And in those cases where we try to use these vehicles, obviously those temperature constraints would get violated. It is not that the engineers don't take this into account. They do take into account. But, since this technology is new, obviously mistakes would be made. And I think we engineers will have to learn how to learn from these mistakes and try to overcome these problems. But otherwise, even the technology perspective, from the battery technology perspective, there are a lot of research, promising researches taking place. We have seen some good results. So another 5-10 years, we can overcome these issues.
So within the other 5 to 10 years, I think these electric vehicles will be more popularized, like the current diesel
Yes,
petrol engines.
yes, no doubt, no doubt.
So when we are coming to the mechanical parts, as you have mentioned, when the coming to the service part or the maintenance part, what about the maintenance level? And it will be very less. But mainly, if the battery is damaged, a huge amount has to be invested in that set because it is one of the main crust. So that's why some consumers are still preferring the petrol diesel engines.
Yeah, yeah, true. See, battery is one major constraint. Other constraint is to charge these batteries. See, if you want, if our vehicle, if we take to say a normal petrol vehicle, if you want to, refill the tank, how much time it takes? Say maximum, say 5, 10 minutes. That's it. But for electric vehicles, batteries, it is not like that. To charge the battery, say from 20% to 80%, it would take 6 to 8 hours. There are fast chargers, but even in the fast chargers, which we have seen, it at least takes 30 minutes to 45 minutes, or maybe 1 hour. That's the range. And these fast chargers are not that cheap. It's costly. You need a lot of infrastructure goes on. Okay. So that's one thing. In terms of maintenance, no doubt, because electric vehicles has got very little moving parts. In IC engine, even if you just try to count the number of bolts and nuts, it's much larger than what it is there in a electric motor. Okay, that's one of the reason why the cost of the maintenance cost of electric vehicles is very down. It's very less. But as you rightly said, there is concerns related to battery. But to address that, what the OEMs, the original equipment manufacturers of these vehicles, what they have proposed is they are giving warranty. They say that if anything happens to the battery, they would replace with minimum or no cost. Today, we can see most of the cars, that electric cars, they give battery warranty of minimum 3 years to 5 years. But in future, we can even see that warranty period getting extended to 6 to 8 years. And even though the warranty is for 5 years, it is anticipated that the life would be somewhere around 8 years. So 8 years, even if you see our normal conventional, say, a petrol car, I'm sure today most of us change the car every 8 years or 10 years. So that's why it's comparable. Yeah, but still this concern is there because vehicle battery is cost is almost around 30% of the entire vehicle cost. So that's huge. Nobody would be ready to invest again and again. But yes, that is being taken care by the OEMs, the different companies. They are trying to take care of this, ensuring that it becomes popular with the with the general public.
Another one doubt is that when we are taking the cars, it will be maximum 2.5, 1.5, 2.5 cc. When it's coming to the heavy vehicles, what will be the battery size and what will be the more the battery related issues associated with on a high power vehicles, like more capacity, cubic capacity?
Yeah, see the battery capacity again. No, I do not know the physical size, how much it would amount to, but corresponding. See, we know that this much, say, 1000 cc or 2500 cc engine will produce this much power. Same way, or that much, the same way for the batteries. I know that roughly the value of around cars. It's going to be around we have 400 volts, around 100 Ah, so around 40 kilowatt hour. Okay, that equivalent energy. The size, yes, it is little bit bigger because if you look at the power density of a lithium ion battery, try to compare it with the power density of a petrol or a diesel. It's not the battery size is much larger compared to petrol. But with IC engine size also, I would say that the battery size is much bigger, but not so big that it will become an extra load to the vehicle. Okay, so even in heavy vehicles, yes, battery size is bit large. They may be designed such a way that they would be. It's not just it's the one battery is not made with one unit. It is made up of different cells where they would be connected in series and parallel, and maybe these batteries are distributed such a way that it would improve the mechanical stability of the vehicle. Generally, they are placed below the passenger, and so that the center of gravity is more close to the earth, and it improves the stability. Yes, if you try to compare the weight of the battery and with the IC engine, I would say that battery size and weight will be much higher than an IC engine for heavy vehicles. That would be an added load, but if you look at the benefits, it's huge. Okay, because at the end, what happens is we just have to calculate how much diesel we are burning to for the same energy. Suppose we want to travel from A to B, we are traveling with a conventional IC engine bus, and if you try to see the amount of diesel or fossil fuels burnt from the same distance, it is much less. So that's what matters.
What are the future research associated with these electric vehicles? Like, as you have mentioned, the battery size. So if you're going for some of the renewable energy sources like the wind, the solar, how it can be associated with the conversion? There also the power conversion is happening, because from
Yes.
one source of energy to another it's happening. So power electronics also plays a vital role. Like as you have mentioned, it's combination of electronics like semiconductor devices like acting a conversion. So in
Yes.
such cases, what are the research scope associated in this field of power electronics in this association with renewable energy,
Yes.
in this combination of cell technology?
Yeah, power electronics has got huge potential in all these areas, and one reason why renewable energy became popular again was because of the advancement of power electronics. So today, the technology, the renewable energy technology, is far matured. One reason, main reason for that is because of power electronics. As you rightly said, if you see the wind, okay, it's not continuous; it is intermittent. It all depends on environmental conditions. But if you look at our AC lines, they are all fixed, the fixed voltage, fixed frequency. Whereas wind, it has variable voltage, variable frequency. So you need some sort of a conversion to handle these variations. And that's where power electronics plays an important role. Even if you see solar, even though solar is actually, it produces DC power. Okay, depending on the sun insolation, it will produce a DC power, and it will keep varying. It's not that maybe at the peak summer the voltage will be at a particular level. When it is cloudy, it will be at another level. Okay. Now, how is power electronics research in this field where there are numerous? Now, how to convert, how efficiently to convert energy from solar PV to wind and connect it to grid? That is where people are trying to work out. People are trying to come up with new power converter topologies. They are trying to come up with new control methods to control these power converters, so that you can extract maximum energy from these renewable energy sources. Okay. Even though the power conversion takes place, it is with some losses. Now there are also a lot of research taking place how to minimize these losses, how to make the power converter efficiency much closer to 100%, though 100% is not possible practically, but at least we can reach a little bit more closer. So a lot of research on that. And even people started even thinking, like, say for example, renewable energy, if you try to take a solar panel, we are placing it around our roof, we can have a scenario where there can be partial shading, where some part of the panel is shaded, some part is not shaded. That will deteriorate the performance of the panel. Now with power electronics, there are suitable methods to ensure that even under such scenarios we can try to extract power. Okay, so a lot of research is going on that. And another major area in power electronics where a lot of research is going on is how to increase the energy density. That means, say, if you try to see a 1 kilowatt or 1 kilowatt power converter, its size is say some X. 100 kilowatt hour, 100 kilowatt, the size of the power converter is going to be much higher. Now we are trying to see how to minimize the size. Okay, just like what we have, no, mobile, the electronics, it is now done. If you see the olden days, older mobiles, yeah, now it's slightly bigger. But if you try to see the olden technology, it is very much bigger. Now we have a little quite compact. So even in power electronics, a lot of research is being going on into seeing how can it be made more compact. And this has got an importance in electric vehicles, because in electric vehicles, size plays a very important role. Okay, so today if you see the power converters going in vehicles, it is much I think one half of what it was 10 years back. Okay, that's all the research that's taking place in these. And if you look at the technology of the electronics that is being used in power electronics, about a decade ago, mostly these electronic devices are made up of silicon. Okay, silicon is the ingredient for all these electronic devices. There is some limitations with silicon. Silicon is, even though it's readily available, but there are some limitations. To overcome that, people are going ahead with the silicon carbide, mixing silicon with carbon and ensuring that you can go with much higher switching. thereby reducing the size. There is another chemistry that is coming up, that's gallium nitride. So even in semiconductor devices for power electronics, a lot of research is taking place. So I would say, to sum up, if you see in the power electronics research, it is on the converter, it is on the control, even the embedded system. See, power electronics needs support from embedded system. Now you may be wondering, what is this embedded system? Embedded system is like some intelligent controller with some associated hardware which will control these power electronics. So even in embedded system associated with power electronics, we have a lot of research taking place. So there are actually numerous fields where research is taking place in the field of power electronics.
So nowadays we can see the concept of hybrid engines. So what is the role of hybrid engine? Actually, we are having the petrol engine, then in between they are telling it's a hybrid. So what's the concept of this hybrid? For the curiosity for the general public.
Yeah, hybrid means combination of two sources. So from an electric perspective, if you only have fossil fuel with IC engine, it is called pure IC engine vehicle. If you only have battery or a fuel cell driving a motor, it's called pure EV. Now there are some vehicles where we use battery as well as IC engine. Okay, the idea there is to reduce the amount of fossil fuels consumed compared to a pure IC engine vehicle. So if you try to use these combinations, now you may be wondering, why do we need to have this combination? Well, that's mainly because of the drawbacks in the electric vehicle. And the drawback in electric vehicle is, to charge the vehicle, you need a lot of time. So what people have come up is, we can charge the maybe once the charge goes below a particular value, we can charge the battery using IC engine inside the car. Okay, so you can use both. Okay, that is IC engine which will assist the battery in propulsion. Also IC engine which is going to charge the battery when we are driving. And we have an option. It is like, you would have heard that we have a hybrid vehicle in terms of LPG vehicles, and CNG vehicles, and petrol vehicles. So there, that concept is there long back. So we have a situation, most of the auto rickshaws, they come with CNG. It is not that they are purely based on CNG. They can also switch over to the IC engine. So if CNG gets over, they can switch over to IC engine and drive. Similarly, if petrol gets over, they can use the CNG and drive. So hybrid is to have the combination of both, an advantage of both. That's the reason the hybrid. But the issue with hybrid is, it's complex. When you have two sources, to manage them, it becomes difficult. So the complexity of engineering also increases. And that's the reason, hybrid, there are some limitations, but there are positives as well.
Okay, thank you, Dr. Prajo, for sharing your valuable time with this forum. It's like a sharing of knowledge or sharing your research experience, which will be beneficial for the student and the faculty. So I hope that in future, with the new NEP policies and all, irrespective of the university, all the institution will be having much autonomy in doing research in like interdisciplinary areas. As you have mentioned, in the case of power electronics, like it can be linked with this embedded system where electronics is coming, then wireless sensors or AI is coming. So I think this was a wonderful session of sharing your knowledge. So thank you for being with us. So I convey my gratitude and regards for being with us. Thank you.
Yeah, thank you, Dr. Hari. It was really a pleasure and honor to be associated with this interactive session. Yeah, I just explained whatever knowledge that I have, whatever I have learned being in industry and through the being in the academic life. Yeah, it's always a pleasure. If there is anything in the future, I'd again be very happy to participate in such interactive sessions.
Thank you. So next session, I think we will be meeting with the students also. So it is a wonderful evening with you, spending the late evening for this purpose. Thank you.
Thank you so much. Thank you.